Describing waves. In this module, you will learn what a wave is and how it is described. Throw a pebble into a pond whose water is still. You will notice a few circular ripples or disturbances that seem to move outward on the surface of the water. These ripples or disturbances are described by using the term wave. So what is a wave? You may think of a wave as a spreading of disturbance from one place to another. The source of any wave is a vibration or oscillation. When you throw the pebble into the pond, it causes the water molecules to vibrate. This vibration causes a wave to propagate in still water. Fix one end of a rope to a wall as shown. Now hold the other end of the rope and move it up and down. These up and down movements produce a vibration that causes a wave to move along the rope. Interesting, isn't it? This is a graph of the displacement of the rope along its length at a certain instant of time. The arrows in the graph show the direction of motion of the particles in the rope. A shorter arrow means a slower speed, while a longer arrow means a higher speed. The dots, that is the particles, without any arrows mean that they are momentarily at rest. A wave or a wave motion as produced in the rope is described by using certain terms. These are crests and troughs, amplitude, phase, wavelength, frequency, period, wave speed, and wave front. You will first learn about crests and troughs. The wave produced in the rope is a transverse wave. In a transverse wave, the motion of the individual particles of the medium is in a direction perpendicular to the direction of the propagation of the wave. Look at the graph carefully. Do you see certain points that are highest? Well, these points are the crests, and the lowest points that you see are the troughs. To be more precise, crests and troughs are the highest and the lowest points respectively of a transverse wave. The highest and the lowest points of a longitudinal wave are called compressions and rarefactions. A longitudinal wave is a wave in which the motion of the individual particles of the medium is in a direction parallel to the direction of the propagation of the wave. Amplitude is the maximum displacement of a crest or a trough from the rest or central position in either direction. In other words, it is the height of a crest or depth of a trough measured from the rest position. Its SI unit is metre. Take a close look at the diagram. Do you see the points marked X and X dash and Y dash? X and X dash are said to be in phase, so are Y and Y dash. Two points are in phase when they move in the same direction and have the same speed and the same displacement from the rest position. Any two crests or troughs are always in phase. Wavelength is the shortest distance between any 2 points on a wave that are in phase. The two easiest points to choose for a distance of one wavelength are two successive crests or troughs. The SI unit of wavelength is metre. Frequency is the number of complete waves produced per second. From the graph you can observe that 2 complete waves are produced. Now, if these 2 complete waves are produced in 1 second, you say that the frequency of this wave is 2 waves per second, or 2 hertz. Hertz is the unit for frequency. Period is the time taken for one point in the wave to complete one oscillation. This is also the time taken to produce one complete wave. The unit for period is second. This implies that the equation relating to period t and frequency f is given by t is equal to 1 over f. Wave speed is the distance traveled by a wave in 1 second. In a time of 1 period, a crest or a transverse rope wave will have moved a distance of 1 wavelength. Therefore, the speed of a wave v is given by wavelength over period, that is lambda over t. Since frequency is equal to 1 over period, wave speed can also be written as frequency into wavelength, that is f into lambda. A wave front is an imaginary line on a wave that joins all points which are in the same phase. You can draw a wave front by joining all the crests of a wave. The wave front is always perpendicular to the direction in which a wave travels. Depending on how a wave is produced, the wave front can be concentric circles or plain straight lines. In this module, you've learned the following. A wave is a spreading of a disturbance from one place to another. Wave motion can be described by the following terms. Crests and troughs. They are the highest and the lowest points, respectively, of a transverse wave. Amplitude. It is the maximum displacement of a crest or a trough from the rest or central position in either direction. Phase. 2 points are said to be in phase when they move in the same direction and have the same speed and the same displacement from the rest position. Wavelength. It is the shortest distance between any 2 points on a wave that are in phase. Frequency is the number of complete waves produced per second. Period. It's the time taken for 1 point on the wave to complete 1 oscillation. It is also the time taken to produce 1 complete wave. Wave speed. It is the distance traveled by a wave in 1 second. Wavefront. It is an imaginary line on a wave that joins all points which are in the same phase.